of the other data structure that was started in arrays and sets, which was last class. So what was arrays and sets? What do you remember about arrays and sets? What is it? Lists, tuples, what do we discuss there?
Arrays start at 0.
Say it again.
Arrays start at 0.
So the elements start at 0, okay. But what is it? What's the array? What's the list? What's tuples?
Sets is like math. Like an equation.
No. Arrays, lists, tuples, these are part of data structure. It's a way to organize data, right? It's a way to organize data. And this dictionaries and sets continues based on what we discussed there. Some of the organization we have discussed, some of them you can change and some of them you can change. And the term we have used was what? Mutable and immutable, right? So we're continuing with that concept here. Again, these last two sessions, we are not doing any work on it, but it's a concept that you kind of need to know as you move forward. But as you go to higher level course, then you have to actually be able to implement it. Now, dictionaries was an object that stores a collection of data. Each element consists of a key and a value, often referred to as mapping of a key to a value. Key must be an immutable object. What does that mean?
It cannot be changed.
Right. It cannot be changed. So to retrieve a specific value, you use the key associated with it. So the format for creating a dictionary is dictionary equals key 1, value 1, key 2, comma, key 2, value 2, key 3, column, value 3, and so forth. Okay, elements in the dictionary are unsorted. So general format for retrieving a value from a dictionary is dictionary and then the key, which is the element that you're trying to access. If key in the dictionary, associate value is returned, otherwise key error exception is raised. So test whether a key is in a dictionary using the in and not in operators. So these are Boolean. It will just check whether it's true or false. Helps retrieve key, prevent key error exceptions. Dictionaries are mutable objects, meaning they are changeable. So to add a new key value pair, you use dictionary and then the key you want to change and then to the value you want to change it to. If key exists in the dictionary, the value associated with it will be changed. To delete the key value pair, then you say del as in delete and then dictionary and then the key that you want to delete. If key is not in the dictionary, then the key error exception is raised. Length function is used to obtain the number of elements in a dictionary. So keys must be immutable objects, but associated values can be any type of object. So one dictionary can include keys of several different immutable types. So values stored in a single dictionary can be of different type. Remember with arrays, it was what? It had to be the same type for arrays. It was either integer or it was either string, it was either character and so forth. But with dictionary, values stored in a single dictionary can have a different type. It can be a string, it can be an integer, float, and so forth. To create an empty dictionary, you use the brace. So you use built-in function dict and then the parentheses as a function. Elements can be added to the dictionary as program executes, and you can use a for loop to iterate over a dictionary. General format for a key in a dictionary, it's for key in dictionary. And then to clear, you have a clear and get. Clear method deletes all the elements in a dictionary, leaving it empty. And the format is dictionary.clear. This is a built-in function part of the library. Get method gets a value associated with a specified key from the dictionary. Format is dictionary.get, and then key and default. Default is returned if key is not found, alternative to the bracket operator. Cannot raise key, error exception. Items method returns all the dictionary's keys and associated values. Format is dictionary.items. Again, this is a built-in function, part of the library, package library. returned as a dictionary view. Each element in a dictionary view is tuple, which contains a key and its associated value. You use a for loop to iterate over the tuples in the sequence. You can use a variable which receives a tuple, or can use two variables which receive key and a value. You have keys method. It returns all the dictionary keys as a sequence. The format is dictionary.keys. You have the pop method, returns a value associated with specific key and removes that key value pair from the dictionary. And the format is dictionary.pop and then key.comma default. The default is return if key is not found. You have pop item method, returns a randomly selected key value pair and removes that key value pair from the dictionary. The format is dictionary.pop item. Key value pair returned as a tuple, so values method returns all the dictionary values as a sequence. And you can use a for loop to iterate over the values. These are just some of the built-in functions or methods. These are not all. Then we have what's called sets. These objects that store a collection of data in the same way as a mathematical set. All items must be unique. Set is unordered, and elements can be of different data types. This is the same as the dictionary, right? A set function used to create a set for an empty set calls, and then you can use set and then the parentheses. For non-empty set, call set is arguments, where argument is an object that contains iterable elements. An argument can be a list, a string, or a tuple. If an argument is a string, each character becomes a set element. For set of a string, pass them to function as a list. If an argument contains duplicates, only one of the duplicates will appear in the set. You have, again, the len function, returns the number of elements in the set, which is similar to what we have seen in the dictionary. Sets are mutable objects, meaning what? They can be changed. You have an add method, adds an element to a set, and you have an update method, adds a group of elements to a set. And then you have arguments must be of sequence containing iterable elements, and each of the elements is added to the set. You have a remove and clear method. Remove and discard methods remove the specified item from the set. The items that should be removed is passed to both methods as an argument. Behave differently when the specified item is not found in the set. Remove method raises the KeyError exception. Discard method does not raise an exception. This is the only difference here. The clear method clears all the elements of the set. You can use a for loop to iterate over elements in a set. So general format is for item and set. Remember the other one was for key in dictionary. The loop iterates once for each element in the set. So the in operator can be used to test, meaning that you see if it's true or not, if that value exists there, whether a value exists in a set. Similarly, the not and operator can be used to test whether a value does not exist in a set. Again, these two are Boolean, right, to see whether it's true or not. Union of two sets, a set that contains all the elements of both sets. You remember this union in math? What's the symbol that's used? If A had A and B, if A had 1 and 2 and B had 3 and 4, A union B would be what? You remember in math? Now let's see. Have you guys taken 112 math or no? Okay, so if A is, let's say, and you have a set of 1 and 2, and let's say we had B, which was 4 and 5, then A unioned with B would be the set of 1, 2, 4, 5. Does that make sense? This would be the union. So a set that contains all the elements of both sets. To find the union of two sets, use the union method, or you can say set1 dot union set2. Or you can use this symbol, okay? The bar operator set1 set 2. So both techniques return a new set which contains the union of both sets. Then you have what's called intersection of two sets. So a set that contains only the elements found in both sets. Okay, so to find the intersection of two sets, use the intersection method, format set1 that intersection set2, and you can use the AND operator. So set1 ampersand set2. Both techniques return a new set which contains the intersection of both sets. So for example, if A was 1 and 2, and let's create another one. Let's say if C is 1, 2, and D is 2 and 5, let's say, then this would be C, which is the symbol for intersect. D would be, what do you think? 2, very good. So this would be 2. Okay, the one that they have in common. Okay, remember the same way the AND we had. Okay, difference of two sets is a set that contains the elements that appear in the first set but do not appear in the second set. Same way difference as subtraction type. So to find the difference of two sets, use the difference. So set 1 minus the difference, or you can say set 1 minus set 2. Symmetric difference of two sets, a set that contains the elements that are not shared by the two sets. So to find symmetric difference of two sets, so this is again the elements that are not shared by the two sets. So in the case here, it would be what? This one, C and D would be what? 1 and 5, right? There you go. Okay, so to find symmetric difference of two sets, you use the symmetric underscore difference method. So it's system set 1 dot symmetric underscore difference set 2. Or you can use the caret symbol or the power symbol, however you want to say. So set A is a subset of set B if all the elements in set A are included in set B. So to determine whether set A is a subset of set B, so use the is subset method. Okay. So and the symbol that's used is the set A, like less than or equal to set B. Set A is a superset of set B if it contains all the elements of set B. So to determine whether set A is a superset of set B, you can use is superset. Again, these high-level built-in functions, we go through this as a concept, but you will use it in the next Python class, the higher level class. They have a 200-level course that they offer. So some of these concepts that we are touching on about arrays, about sets, about recursion, and the dictionary and sets, once you get to that class, you will go over it. All right. Now, what I want to go over is all of you pretty much submitted, I think, all your project 4 and your exams. The only thing I wanted to go over, and just to remind you, was the projects you had due for 5 and 6. 5 and 6 is basically a continuation of what we left off on project 4, which I believe all of you have submitted. And this project, the only thing you had to do was add a loop to enable the user to run the Python program all day without restarting the program. So you ask the user, basically, is they another customer? When you add the loop, also add a continuous process, another order. You can output the number of orders processed that day, how much money those orders were worth, and if possible, you tax the discount. All this code can be in the main, should still be fitting on one screen. And then you can check an error checking loop that will only exit when the user enters and enter the value as cash tender that is more than the total amount owed. So this whatever you need for this project had been covered if you go back and look at the videos in Unit 6 and Unit 5. As far as the loop and the error checking going back, you can look at Unit 5. As far as the functions, go back and look at the videos that we have discussed on creating functions for that project 5, because it's continuation of where you left off project 4. So if you get to the end, you will see basically taking orders and then creating functions. We discussed it in here. Now, once you create your functions, then you go back to that Unit 5 and look at how we created loops. This is where we showed functions. Remember your last project had functions? So you'll be converting everything into functions and then creating that. All right, so that will help you creating the functions that you had. And then going back to the videos we have covered repetition, or the loops that is discussed in here, these loops that you're going back and asking the user, then you can go back to that video that we have discussed in repetition in Unit 5. Again, you will see this again with the Python part will be the ending of it. And you will see how we apply it. Again, in your case, you definitely don't need for loop. You actually need a while loop, because for loop, we know how many times that you're trying to run, but you don't know how many customers you're having. Therefore, you will be using a while loop, like I'm using a while loop here, so that if the user wants, if there's another customer, then you have to, is there another customer? If the answer is yes, then you will run that program again. So that's what you have to do for that project 5. It's a combination of Unit 5 and 6 that we originally discussed. Now for the project 6, it's basically going back to Unit 4. What did we discuss about Unit 4? Unit 4 was what? If-else statement. So project 6 asks you about creating a Python program that determines the grade for an individual. Students based on his or her average in class. The program will include a loop that will perform, again, the loop would be that project Unit 5, until the user wants to quit it, the same way as the other one, right? But then again, you ask the user, what is the midterm exam? What is the final exam? And then you use exactly this formula. Average equals midterm times 40%. What is 40%?
0.4.
0.4, very good. And then final grade times 60%, which is 60%, 0.6. Now, if a student has an average of greater than 59, he or she passes the course. But if the average is less than 60, here I say 59, here I say 60. Just be consistent with one number. If you use 59 here, use 59 here. If you use 60 here, use 60 here, okay? It doesn't matter which one, just be consistent. In either case, display a message that is stating whether the student has passed or failed. Okay, at the end of the program, display a message telling the user how many students' grade were processed and so forth. Right? Also display how many students passed and how many students failed. All right, so these two, again, projects, for those of you that started already, it's not something new that we are covering. It's previously what have been covered in previous units. Okay, on Unit 4 for the decisions, but 5 and 6 is what you need. 6 for the functions, and then 5 for the repetition for the while loops that you will need for both projects. All right. Again, these units that we have covered, we didn't have anything that you had to use for your projects. Okay, and then for the project 7, you will need classes and object-oriented program, which is what we will discuss in the next class. All right. I think about half of you already submitted exam 2. Make sure you submit and you don't fall behind. All right. That's it.